Power and energy. Power and energy are two terms that are used in physics in more fields than just electricity. Energy refers to the total amount that's done. If we imagine an electrical device, we say the total amount that electrical device has accomplished. It's a little tricky because it depends on the type of electrical device. For example, a speaker, we'd measure its energy as the total amount of sound energy that it had produced. Or a light bulb, we might imagine its energy as the total amount of light that has been produced over a period of time. I guess if you imagine something like a refrigerator, you could imagine the total amount of change in temperature, the total amount of thermal energy that the device has done. Power, on the other hand, is related to energy, but it wants to know how much energy we have per unit time. So when I think about power, I often think it helps to understand some devices that have high power and some devices that have low power to help you understand. So an example of a device that has high power is something like your toaster. Your toaster goes on for a very short period of time, and it heats up your toast very quickly. And so although it doesn't use very much energy, it uses a lot of energy in each second, and so it has a high power. Alternatively, something like your refrigerator, which is well insulated and keeps the temperature just a little bit cold in your house, uses a lot of energy over time, but it does not have a high power. It does not use very much power in any 1 second. So this is like the total, and this is like the rate. To make this related to something maybe more concrete, we can imagine traveling a large distance, and this would be like the distance you travel. And this is a little bit like your speed. It's like how much energy you're doing in 1 second. To summarize these things, we say that energy is given the symbol E, power is given the symbol P, so those are nice and simple. And the unit, energy, is measured in joules. Joules are related to units of force and distance, and we'll discuss those in more detail a lot later if you take grade 11 physics, but for now we'll just leave it alone. And power is measured in watts. 1 watt is equal to 1 joule in 1 second. And finally here, the relationship power is equal to the amount of energy, or the total amount a circuit does, per unit time, T, or in each individual second. Well, how do these relate to voltage and current? Well, if we recall, voltage was the amount of energy per unit charge that moves around the circuit. So voltage is energy per charge. Current was the amount of charge that will move around the circuit in a given amount of time. And so if I want the amount of energy per unit time, or the power, then I can multiply these two things. Voltage and current, and I can see that the charge will cancel out. And if I take my voltage, energy per unit charge, and my current, charge per unit time, I can get my power. So, power is how much work you're doing every second. Energy is the total amount of work done over a long period of time or a short period of time. And we use these symbols. And by definition, we get this definition that this equation, power is equal to the energy divided by time. And thinking about them in terms of voltage, recognizing that voltage is energy per unit charge and current is charge per unit time, I can see that if I multiply my voltage and my current, the two charges will cancel out. I'll get energy per unit time, which is power. So I get this secondary equation. which I know I wrote it that way, but is typically written P equals IV. So that is power and energy.